Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind, and knowledge becomes a soft lullaby for the night. Tonight's journey will take us into one of the most mysterious questions ever asked. What if time itself could end? Not just the ticking of a clock or the passing of a season, but the very fabric that lets things happen one after another. But before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe. Only if you truly find these quiet explorations enjoyable. And when you're ready, leave a comment to let me know where in the world you're listening from and what time it is for you right now. It's always such a joy to see all the places we gather from, each in our own little slice of time. Now, feel free to dim the lights, maybe turn on a fan for a soft background hum, and let's gently begin our journey into the paradox of time that scares scientists. If your mind begins to wander, that's perfectly fine. Let it drift. We'll still be here, quietly unfolding the story. You've seen endings before. A candle burns out, a leaf falls, a song reaches its final note. Yet each of those endings is also a beginning in disguise. The candle's smoke curls upward to meet the air, the leaf feeds the soil, and the silence after a song leaves room for another melody to bloom. Life, it seems, is built from endings that turn into something else. But what if one day there were no something else? What if endings stopped leading anywhere? What if there came a moment, not just for a person or a planet or even a star, but for everything, everywhere, when nothing followed after? It sounds impossible, almost poetic, the end of all endings. Yet modern physics quietly admits this may not be poetry at all but prediction. According to our best theories, there could come a time when even time itself runs out. The universe, which once unfolded in waves of birth and decay, might one day freeze in perfect stillness. No future, no motion, no heartbeat of cause and effect, just an eternal pause, the ultimate quiet. Before Einstein, few minds worried about such things. Time was considered simple, a steady beat that the universe followed without changing tempo. Philosophers imagined it like a ruler or a river, endlessly smooth, always flowing forward. But Einstein showed us a deeper rhythm. He revealed that time can bend, stretch, or slow down, depending on how we move and how heavy our surroundings are. Imagine the universe not as a ticking clock, but as a vast musical jam session. Galaxies, planets, and people all playing their own rhythm, their beats overlapping, sometimes drifting out of sync. Gravity in this cosmic orchestra slows the tempo. Motion can make it quicken. Time isn't separate from space. It's part of the same grand composition, space-time. A fabric that can warp and fold like a sheet of music under stress. But what happens when that fabric tears? When the notes pile so high they crash into a wall of silence? Physicists call those limits singularities. They are regions where the equations we trust stop making sense, where the music of space-time burns out, leaving behind only static. The Big Bang was one such moment, the beginning of the universe, and perhaps the first edge of time. A black hole might be another, swallowing not just matter and light, but the very order of moments. From the outside, it looks like an object collapsing. But from within, something stranger happens. Time itself grinds to a halt. If you fell into a black hole, your story would end in a way unlike any other ending you've known. Not the slow fading of life, but a kind of existential collapse. Your own timeline, the thread connecting one heartbeat to the next, would simply stop existing. Outside, the universe would go on, stars would shine, and clocks would keep ticking. But for you, inside that gravity-warped region, the word after would lose its meaning. There would be no next second, no next anything. This thought disturbed Einstein himself. He could calculate such regions in theory, but he didn't believe nature would allow them to exist. The idea that time could end in certain places seemed absurd. Later, physicists proved that his equations did in fact lead inevitably to singularities, both at the beginning of the universe and at its deepest centres of collapse. These are not catastrophic explosions, but rather points where the language of physics loses its grammar, like a sentence that never finishes, or a word that dissolves halfway through being spoken. And yet, the more scientists have studied these limits, the more they've realised something profound. Singularities might not mark the destruction of time, but rather the boundary where our current understanding stops. Just as a horizon hides what lies beyond, these limits may conceal a deeper continuity, one we don't yet have the tools to describe. Perhaps where time seems to end, something else begins, something without clocks, without direction, without the familiar comfort of before and after. It's unsettling to imagine. You might picture the entire universe freezing mid-breath, every motion locked forever, like frost capturing the surface of a pond. But even that image is too still, too familiar. When physicists speak of the end of time, they don't mean a frozen moment we could observe. They mean a state where the very concept of moments no longer applies. If time measures change and change itself stops, then what's left to count? For now, these are questions balanced between mathematics and mystery. Our equations point toward limits, but our curiosity insists those limits aren't final. Somewhere beyond the numbers, beyond the metaphors and the fear, there may be another way of existing, not without time, but beyond it. As we drift further into the story, we'll explore what happens when that steady rhythm of time falters, when black holes trap it, when the universe stretches it thin, and when our own minds try to imagine a world that keeps existing after time itself has vanished. But for now, let's rest here, at the threshold of a question so vast it almost hums. If endings can end, what still remains? If you close your eyes and listen carefully, you can almost hear it, the quiet rhythm that has guided the universe since the first moment we could imagine. Before Einstein's time, that rhythm was thought to be steady, unchanging, like the tick of a perfect clock that never needed winding. Every star, every grain of sand, every heartbeat was believed to move in time with the same invisible pulse. Newton's universe was like a grand concert hall filled with precision. Every planet spinning in predictable motion, every second identical to the one before it. For centuries, this view brought comfort. Time was simple, measurable, obedient. It flowed like water from a fountain that never ran dry. You could divide it endlessly, minutes into seconds, seconds into fractions of seconds, and still it would behave, flowing evenly through the gears of every clock, through the lives of every person. It was the stage upon which the universe performed, never part of the performance itself. But the 20th century began to whisper a different tune. Einstein, with his patient mind and stubborn sense of wonder, listened more carefully. He noticed that the universe doesn't keep perfect time, that its rhythm can shift, stretch, or slow depending on how you move and where you stand. To him, time was not a drum beating alone in the distance, but part of a vast orchestra where motion and gravity all play together, sometimes harmoniously, sometimes not. Imagine for a moment you're on a fast-moving train at night. The lights along the track flash by, and the hum of the engine fills the air. Inside, everything feels still. Your coffee sits calmly in its cup. Your heartbeat doesn't notice the speed. Yet to someone standing outside on the platform, you are racing by at hundreds of kilometers per hour. Einstein realized that both views are true, and that time itself must adjust to keep them both consistent. When you move faster, time stretches. A clock in your hand ticks more slowly than a clock at rest. The difference is tiny at ordinary speeds, barely noticeable even for the fastest jet. But as you approach the speed of light, the effect grows stronger. To an observer watching you from afar, your seconds begin to lengthen, your heartbeat slows, your whole existence seems to pass in slow motion. For you, though, everything feels normal. Your thoughts, your breath, your steps, all move in perfect rhythm with your own clock. Einstein called this time dilation, but it's easier to imagine it as the universe adjusting its tempo, keeping harmony among all its players. Where gravity is stronger, as near a massive planet or star, time itself slows down a little. Where gravity is weaker, it flows more quickly. Time doesn't simply march forward. It responds to the presence of energy, to the curves and folds of space. It stretches around mountains of matter, like music bending around a drum. The most famous example of this dance is what scientists call space-time, a single woven fabric where space and time are inseparable threads. When an object with mass, like Earth or the Sun, sits upon this fabric, it causes a gentle dimple, a curve that other objects follow. That curve is what we experience as gravity. You might imagine a soft sheet stretched tight, and a heavy ball resting at its centre. Place a smaller marble nearby, and it begins to circle the heavy ball, not because it's being pulled, but because the surface beneath it curves inward. Einstein's insight was that this curve affects not only where things move, but also how time flows. Clocks lower in the gravitational well, closer to that heavy ball, tick more slowly than those higher up. If you were to stand at the base of a mountain and your friend stood at its peak, your friend's watch would race ahead by the smallest fraction of a second each day. The difference might be less than a few billionths of a second, but it's real and measurable. Satellites orbiting Earth must account for this effect to keep your phone's GPS from drifting off course. It's astonishing to think that your morning coffee, brewed at sea level, is aging ever so slightly slower than a satellite circling above you. But in Einstein's universe, this is not an error. It's the nature of reality itself. Time bends and stretches to keep balance between motion and gravity, between perspective and place. And so the universe became less of a metronome and more of a jazz band. Each instrument, each planet, each particle follows its own rhythm, improvising within the rules of relativity. There is no conductor, no absolute tempo, yet the music still holds together, rich and unpredictable. You're part of that orchestra too. Every time you move, every time your heart beats, you're subtly altering the tempo of the time around you. A tiny note in a cosmic song. But every orchestra has its limits. Sometimes a musician plays so fiercely that their instrument burns out. In the same way, space-time can be pushed to its extremes. When gravity grows too strong, as inside a black hole, the rhythm collapses entirely. The beat doesn't just slow, it stops. Time in that region loses its ability to move forward at all. The music falls silent. This, perhaps, is what makes the idea of relativity both comforting and haunting. Time is flexible, yes, but not unbreakable. It can stretch like taffy, bend like light through water, but there are edges where it reaches its limit. Scientists call these edges singularities, points where the universe's music stops playing by its own rules. We'll come to those edges soon, but for now, let the thought settle gently in your mind. The seconds you feel are not universal. They are yours, personal, local, stitched from your motion and gravity's touch. The universe does not march to one clock, but to billions of rhythms woven together. And if time can slow, if it can bend and twist, then perhaps it can fade too. Not vanish in an explosion, but sigh softly into stillness. As we drift further into the story, we'll explore what happens when those gentle curves of space-time deepen into wells so steep that even light cannot escape, and when time itself, that quiet musician keeping rhythm beneath it all, begins to forget the next note. Every rhythm, no matter how beautiful, carries within it the chance of silence. Even in music, there's a moment when the drummer strikes too hard, when the beat collapses into noise and all that's left is the hum of what once was. In the universe, such collapses exist too. They are called singularities, places where the Smooth rhythm of time and space falters, and the cosmic orchestra forgets its melody. You can picture them as boundaries, not walls that stop you physically, but horizons where meaning itself begins to fade. A singularity isn't a thing, not really. It's the point where our understanding ends. Imagine writing a song so complicated that, near the final page, the notes tangle into scribbles your mind can't interpret. The ink runs together, the music becomes silence. That's what a singularity is for physics. The part of the song the universe keeps playing, but we no longer know how to read. The most famous singularity lies at the beginning of everything, the Big Bang. We often imagine it as an explosion, a fiery eruption that scattered galaxies into the void. But that's not quite true. The Big Bang wasn't an event inside space. It was the moment when space itself began to exist. There was no before, because there was no time yet. Every planet, every atom, every breath you've ever taken traces back to that moment, when all matter and energy were compressed into a region so dense, so tightly folded, that our equations break. Scientists describe it using terms that sound clean and mathematical. Infinite density, zero volume. But infinity isn't a number you can reach. It's a warning sign. It tells us that something about our model no longer fits the universe. Just as light doesn't actually focus into a perfect point, it spreads into a soft pattern. The Big Bang might not have been an exact point either. It could have been a small, seething blur where quantum ripples smoothed the impossible into something real. Yet, whatever its true shape, it marked the first known boundary of time. Now imagine the opposite. Not a beginning, but a collapse. A dying star, once brilliant, begins to run out of fuel. Its light flickers, and gravity, the same gentle curvature that keeps planets in orbit, grows fierce, unbalanced. The star implodes. Its atoms, once held apart by heat at pressure, fall inward. The deeper they fall, the more gravity pulls, until not even light can climb back out. What's left is a black hole, and at its centre, theory predicts, lies another singularity, a region where time ends once again. If the Big Bang was the first beat of the cosmic drum, then a black hole is where the drummer's hand collapses into silence. The rhythm that carried a star's life, its pulses, its nuclear fire, condenses into stillness. The laws of physics, which have carried us faithfully through every sunrise and falling apple, cease to apply. Distances vanish, time loses direction, and the universe, at least locally, stops breathing. But there's a strange elegance to this end. From the outside, a black hole looks calm, even graceful. It doesn't explode or rage, it simply holds. Gravity pulls inward perfectly, quietly, endlessly. The event horizon, the boundary beyond which nothing can return, is like the edge of a mirror turned dark. From our perspective, anything falling in seems to freeze just before crossing, its light stretching, reddening, fading to black. To the falling traveller, though, nothing unusual happens at first. There's no sudden wall, no warning, only the growing pressure, the unstoppable pull, and then in the deepest core, time itself stops having meaning. It's a haunting symmetry, a beginning that looks like an ending, and an ending that echoes the beginning. The Big Bang and a black hole are mirrors facing one another across the cosmic hall, each a singularity that curves the flow of time so sharply that our mathematics trembles. To physicists, these singularities are both terrifying and tantalizing. They're not just the failures of theory, they are clues. They whisper that something beyond Einstein's equations is waiting to be discovered. When Einstein first found that his own mathematics predicted singularities, he didn't believe it. He thought nature would prevent such absurdities, that the universe would somehow smooth them out. But decades later, other scientists, Stephen Hawking, Roger Penrose, and many others, proved otherwise. They showed that under very general conditions, singularities were not accidents, but unavoidable. Gravity, when left unchecked, leads inevitably to collapse. The drummer will burn out. Yet there's a kind of mercy in this realization too. These cosmic failures tell us that the universe has limits, that even its most elegant rules bend at the edges. They remind us that our understanding, no matter how vast, is still human. When equations whisper infinity, they're not describing the world, they're describing the point where we must stop and listen. Perhaps what frightens us most is not that time might end, but that it can end locally. The rest of the cosmos goes on while a region, a story, or even a person reaches a final page. Imagine a library where some books simply stop mid-sentence while others continue beyond. Black holes, in a way, are those unfinished stories. They contain chapters we'll never read, words that exist but are sealed away behind horizons we cannot cross. And yet, even in that silence, something endures. The information carried by what falls into a black hole may not be truly lost. It may be rewritten, encoded into the surface of the horizon itself. Like a melody played backward, its meaning transformed but not destroyed. This idea, still debated, still mysterious, hints that perhaps time does not truly end but changes its form. So the singularity is not simply a void, it's a question mark carved into the universe. It asks whether endings are absolute, or whether they are simply boundaries we haven't yet learned to cross. The drummer may burn out, yes, but somewhere beyond that last crashing note, there may still be silence waiting to become rhythm again. If we follow the thread a little further, we'll find that this struggle between what ends and what continues isn't new. Philosophers have wrestled with it for millennia, long before telescopes or equations. They wondered not just whether time could stop, but whether it could ever have truly begun. And in their paradoxes, we'll find the echoes of the same question haunting modern science. Can something infinite ever really end? Try to imagine yourself drifting toward a star that has died. Its light, once bright enough to cast shadows across worlds, now bends inward, a glow falling back upon itself. Around you, the universe still moves, distant galaxies breathing, radiation humming faintly like a low cosmic chord. But where you're headed, that hum begins to fade. Gravity grows stronger with every mile, tugging not just at your body, but at the rhythm of your seconds. Time, that loyal companion that once seemed steady, begins to slow down, stretching like warm honey. From far away, someone watching you through a telescope would see you falling slower and slower, as though the universe were reluctant to let you go. Your movements would appear to freeze. Your voice, if you could call out, would stretch into deeper and deeper tones until it vanished altogether. To you, though, nothing strange would seem to happen. You would keep drifting forward, pulled by a force that grows heavier, quieter, inevitable. It is the most private of journeys, the end of a personal timeline. A black hole doesn't simply pull you inward, it pulls you out of sequence. The closer you approach the event horizon, that invisible boundary where light can no longer escape, the more space and time swap their roles. Moving forward becomes impossible. Even turning back loses meaning. The line of your life, which once unrolled neatly, cause, effect, memory, anticipation, begins to fold. Seconds stack upon seconds. What you once called next dissolves into the same moment, repeated forever. For you, the fall continues until you reach the singularity, the region where all paths end. But from the outside, your fall never finishes. You become a frozen image, forever approaching but never crossing that last dark threshold. The universe writes you into its surface, stretched thin across the event horizon like a reflection on water. Your atoms, your story, everything you once were, become information woven into the black hole's skin. It's a strange kind of immortality, not living, not gone, but translated into another language of physics. Physicists call this the information paradox, the question of whether what falls into a black hole is truly lost. According to Einstein's relativity, the answer is yes. The story ends, the pages close, and nothing escapes. But according to quantum theory, information can't simply vanish. Every particle, every vibration, carries its own faint fingerprint, and even the universe cannot erase those prints completely. Somewhere, hidden in the faint whispers of light that escape the black hole's edges, the radiation named after Stephen Hawking, the story may still be told in a form so scattered that no mind could reassemble it. So which is true? Does the story end, or does it continue in another script? The universe refuses to say. Perhaps both are true, and that contradiction is the heart of the mystery. From one point of view, you vanish. Your timeline ceases, your body crushed into oblivion. From another, your pattern lingers in the soft glow at the edges of darkness, stretched thin but not erased. Death and preservation, silence and echo, all happening at once. It's unsettling, yet strangely beautiful. The end of time inside a black hole might not be destruction at all, but a kind of translation. The melody of your existence is rewritten, not deleted, turned from a song into a code, from a pulse into geometry. For physicists, this is more than poetry. It's a clue. If time can end in one form but persist in another, maybe ending isn't the right word. Maybe it's a change of key, a modulation in the universal music. But beyond the physics, there's something human in this idea. To fall into a black hole, to face the point where time runs out, it mirrors something we all understand, even without equations. Every life, no matter how long or how bright, has a horizon. We move through it knowing that eventually there comes a boundary we cannot cross and then return. And yet, as with black holes, what remains of us may not be nothing. The warmth we gave, the thoughts we shared, ripple outward, weaker and weaker, but still there, fading into the cosmic background. Perhaps this is why black holes feel less like monsters and more like mirrors. They remind us that endings, though absolute in one sense, may be only partial in another. Every death of a star, a life, a moment, contributes its energy to something else. The same laws that seem cruel in one light turn generous in another. Even the collapse of a star feeds the galaxy with heavy elements, the same materials that build new worlds and hearts. Destruction and creation are, in truth, two sides of the same gravitational coin. Einstein once said that for those who understand physics deeply, the distinction between past, present and future is only a persistent illusion. In a black hole, that illusion finally breaks. The line of time bends back upon itself until every moment, every heartbeat, exists all at once. What you were, what you are, what you could be, folded into the same curve. It's terrifying to imagine, but also oddly peaceful, a kind of stillness that doesn't erase, only unites. From a distance, the universe carries on as if nothing happened. Stars orbit silently, galaxies spin, and the black hole, patient as stone, holds its secret. Inside, time has stopped. Outside, it moves endlessly. This contradiction, frozen and flowing, silent and singing, lies at the centre of our greatest mystery. The universe does not end everywhere at once. It ends in pockets, in folds, in local silences that remind us how fragile rhythm can be. And so, the end of your story is not a bang, not even a whisper. It's a boundary. One that marks where our language, our science, and our imagination all reach their limit. Beyond it, something may continue, but not in a way we can measure or name. The idea that time can die locally while the universe lives on is both humbling and profound. It tells us that endings are personal, and that perhaps the cosmos, vast and ancient as it is full of small, private silences like this, each one a reminder that even infinity has seams. As we drift further into the story, we'll follow this thread from the quiet gravity of black holes to the philosophers who, centuries before telescopes, already suspected that time could trap itself in paradox, forever looping between the idea of ending and the impossibility of ever truly stopping. There's something haunting about the idea of a mirror that doesn't reflect light, but reality itself. When physicists stare into the equations that describe black holes or the birth of the universe, they find such a mirror, one that doesn't show them a picture of what exists, but a reflection of where their understanding ends. It's called the singularity. In everyday life, mirrors feel safe. They show you what's real, though reversed. But a singularity is the opposite. It shows what can't yet be known. The closer science gets to it, the blurrier everything becomes, until distance, time, and even the idea of cause begin to melt together. It's as if nature has placed a veil between knowledge and mystery, saying gently, "You can come this far, but not yet further." To understand why singularities are so confusing, it helps to remember that our universe is written in the language of equations, instructions that describe how things move and change. But near a singularity, those instructions begin to contradict one another. Imagine reading a map that suddenly tells you to turn left and right at the same time. The coordinates themselves begin to fail. When that happens in physics, we call it infinite curvature or infinite density. But those words are just our way of admitting that our map doesn't fit the terrain anymore. Einstein's equations predict these breakdowns, both at the heart of black holes and at the beginning of the universe, but they don't explain them. They describe how space and time bend under gravity, but not what happens when that bending becomes absolute. At that point, the fabric of space-time stops behaving like fabric at all. It's not that there's something there, it's that the concepts of something and there stop being meaningful. For decades, physicists hoped this was just a mathematical illusion, that if they looked closer, the infinities would vanish, smoothed away by a deeper theory. And so began the search for what they call quantum gravity, a theory that would unite Einstein's grand geometry with the probabilistic rules of quantum mechanics. Both theories work beautifully, but like two musicians playing in different keys, they clash at the edges. One speaks of continuous space, the other of discrete quanta, tiny indivisible packets of energy. Somewhere between those languages lies the truth. It's hard to visualize what such a union would look like, but one idea suggests that the smooth surface of space-time might not be continuous at all. Instead, it might be made of microscopic loops, like a fabric woven from threads so fine we could never see them. When the universe stretches or compresses, those loops twist and interlock, preventing true singularities from forming. The result is not a point of infinite density, but a tiny bouncing knot of geometry, a place where collapse transforms into expansion. In this picture, the universe never truly reaches zero, it bounces. Other physicists turn to string theory, imagining that the building blocks of everything aren't points or loops, but vibrating strings, unimaginably small filaments, each one a note in the cosmic symphony. To them, a singularity might be like a chord played too loudly, the vibrations becoming chaotic, yet still connected to the rest of the song. They propose that near the core of a black hole or the beginning of the cosmos, these strings tangle into higher dimensional shapes, spreading out the impossible density across a broader landscape. The infinity dissolves into harmony, hidden beneath complexity. All of this sounds abstract, but the emotional truth is simple. The singularity is where knowledge reflects ignorance. It's the universe showing us our own limits, the point where our best instruments, our cleverest equations, and our brightest minds all encounter the same silence. It's not failure, it's invitation. Every boundary in science has been a mirror like this. The horizon before flight, the silence before radio waves, the darkness before telescopes could see beyond our galaxy. Each time, we've stared into the unknown, seen our reflection trembling in the surface, and then learned how to step through. Still, there's something poetic about the idea that nature hides its deepest truths inside the very places we cannot see. Perhaps it's a kind of protection, a built-in humility. The universe keeps its most sacred mechanisms just beyond reach, asking us to approach with awe instead of arrogance. For all our progress, physics still faces this quiet question. When we reach the limits of description, what remains of reality itself? Some thinkers have started to wonder whether the singularity isn't just a physical boundary, but a philosophical one. Maybe it doesn't mark where the universe ends, but where our language ends. We can only describe the world using the words we have: distance, mass, time, cause. But what if the universe continues beyond those words, in forms we haven't yet invented concepts for? The singularity in this view is the mirror where human thought meets its own edge. To others, it's a message. The very fact that our equations break down might mean that reality is whispering something. You're using the wrong tools. Infinity, after all, isn't a feature of the universe. It's a symptom of misunderstanding. When a lens focuses light to a single perfect point, the brightness should be infinite. Yet in the real world, it never is. The wave nature of light spreads that focus into a soft ring, preventing the impossible. Likewise, when gravity tries to compress matter into a point, perhaps the quantum wave spreads it back out. The singularity then might be less an end and more a place where the universe insists on softness. It's comforting to think that even in the most violent corners of existence, collapsing stars, exploding beginnings, there might still be grace. That, hidden within chaos, the cosmos refuses to allow true sharpness. Every so-called infinity might be in truth the universe's way of saying, be patient, the picture isn't finished yet. And if we take that lesson to heart, the singularity stops being a wall and becomes a mirror, one that reflects not the end of understanding, but the beginning of humility. It reminds us that mystery isn't a failure of science, it's the breath that keeps science alive. The unknown is not an absence, but a promise. As our quiet exploration now turns to the thinkers who first tried to define that promise, we'll leave the realm of mathematics for a moment and step into the world of philosophy, where time, endings, and infinity have been debated for thousands of years, long before a single telescope ever looked into the night. Imagine a single candle burning in a quiet room. Its flame dances gently, casting moving shadows against the walls. You can almost feel time passing in the soft flicker, each second a tremble of light, each moment feeding the next. Now imagine that same flame lighting another candle beside it, and that one another still. Each ending becomes a beginning. No darkness lasts for long. The world keeps finding ways to glow again. Long before physics could measure time in seconds, thinkers wondered whether this chain of beginnings and endings could ever stop. Among them was a man who loved paradoxes, Immanuel Kant. To Kant, time was not just a physical thing, but a framework of the mind, the stage on which all thoughts and experiences appear. He believed that reason itself leads us into a peculiar trap when we ask about the beginning or end of time. Both possible answers, he said, seem correct, and both seem wrong. If you say that time must have begun somewhere, that means there was a moment before time, which makes no sense because before is already a word that requires time to exist. But if you say that time stretches infinitely backward, you face another impossibility, an endless chain of moments with no starting point, like a story that has been telling itself forever. Kant called this puzzle an antinomy, two opposite statements that are both rational and self-defeating. Time, in his view, is not something that can truly begin or end, because those very ideas depend on time already being there. It's a thought that makes your mind lean in two directions at once, like trying to look behind your own head. The more you turn, the less you see. And yet, that's where the fascination lies. Kant didn't see this as a failure of logic, but as proof that human reason reaches its limits when it tries to grasp infinity with the tools of the finite. Some doors, he said, open only into mirrors. Centuries earlier, Aristotle had wrestled with a similar idea, but with a more grounded calm. He lived in a world without telescopes, yet his sense of motion was keen and intuitive. Watching nature, he saw that nothing truly begins from nothing. Every movement, every change, arises from something else. The falling apple is born from the weight of its stem. The river's flow continues from countless raindrops before it. For Aristotle, the universe was like an eternal chain of dancers, each hand passing motion to the next. There could be no first mover in time, only a mover that is timeless, what he called the unmoved mover, a principle outside change itself. From this, he concluded that time itself cannot stop, because time is the measure of motion. If something moves, time exists. If nothing moves, then before and after vanish. But motion, he believed, is woven into the nature of reality. To imagine time ending would be to imagine everything freezing, every thought, every atom, every breath. He could conceive of death, but not of stillness beyond death. Both men, separated by centuries, were touching the same paradox from opposite sides. Kant looked inward and found the limits of reason. Aristotle looked outward and found the persistence of change. One saw an idea too vast for the mind, the other saw a world too alive to stop. Together they formed a kind of philosophical duet, one voice asking how time could end, the other asking how it could not. When we think of their ideas tonight, we can soften them into something we can feel rather than prove. Picture a circle of candles, each flame lighting the next as it fades. At no point does the light vanish entirely, yet no single flame burns forever. The glow continues, not through permanence, but through passing. That is how Aristotle might see the world, an eternity not of static being, but of motion and renewal. Kant, sitting nearby, might nod in agreement, yet quietly remind us, all of this happens within your perception. If you could step outside the circle, even forever might lose its meaning. Modern physics, with all its instruments and equations, hasn't escaped this old dilemma. It simply uses different words for the same question. When scientists talk about singularities, or the Big Bang, or heat death, they're still asking what happens when before and after breakdown. Does time end at those boundaries, or does it loop, repeat, or reinvent itself? In their own way, physicists have inherited the philosopher's candle, still trying to understand where its light truly begins. And perhaps just like the philosophers, they will never find a final answer, not because they have failed, but because the question may not have one. Time may be less a thing to solve than a relationship we inhabit, like a melody that can't be played backward without losing its rhythm. Even the act of wondering about the end of time requires time to think in, a paradox that folds neatly back on itself. There's a quiet comfort in this realization. The same mystery that puzzled Aristotle and Kant still keeps modern minds awake. And yet, the world continues gently on. Stars rise and fade, lives begin and end, and still the rhythm of existence persists, as if the universe itself has learned to hum through uncertainty. Perhaps the beauty lies not in finding where time stops, but in understanding that it never truly holds still. So, if endings require time to happen, can there ever be a final end? Maybe not. Maybe every ending is just the universe exhaling, preparing for its next breath. The flame goes out, but the warmth remains, and when a new flame catches, we call it beginning. Our path now carries us from these candlelit rooms of philosophy into the brighter halls of science, where the question of infinity waits. There, the language changes from thoughts to numbers, from metaphors to measurements. Yet the same paradox gleams beneath it all, like a reflection on glass. If infinity is impossible, why does it appear wherever we look? There's a certain awe in the word infinity. It sounds almost sacred, a word so vast that it seems to stretch beyond speech itself. For most of human history, infinity belonged to poets and philosophers, a symbol of the divine, of things too big to grasp. But when science inherited it, the word became both gift and warning. It promised discovery but carried a quiet note of caution, like a compass spinning wildly at the pole. Whenever equations point to infinity, they aren't revealing an ultimate truth. They're whispering something has gone wrong. To see why, imagine a beam of sunlight shining through a magnifying glass. The lens bends the light, focusing it onto a small spot. If the math of optics were perfect, that spot would have no size at all. The light would converge into an infinitely tiny point, and its brightness would become infinitely intense. But that's not what we see. Instead, the light forms a small, shimmering circle, its edges soft, its heat finite. Nature refuses to obey our perfect geometry. The idea of infinite brightness is only a ghost of our incomplete model. In physics, infinities behave the same way. When our equations return a number that grows without limit when density becomes infinite or curvature infinite, it doesn't mean the universe truly contains such things. It means the tool we're using has broken. Infinity is the red flag waving at the edge of understanding, reminding us that reality is smoother, gentler, and far more subtle than our sharpest calculations. The ancient Greeks already distrusted the infinite. Zeno's paradoxes, with their endless halves and ever smaller steps, showed how absurd things become when you try to divide motion forever. Achilles, in the myth, can never catch the tortoise if space can be cut into infinite pieces, and yet in the real world he passes easily. The paradox isn't about motion itself, but about the limits of how our minds describe it. Infinity is where the logic of thought outpaces the rhythm of reality. In modern science, infinities appear most famously inside black holes and at the beginning of the universe. At those boundaries, the equations of general relativity tell us that curvature, the bending of space-time, becomes infinite. It's like trying to draw a curve so tight that the pencil breaks. The very shape of reality twists until our geometry gives up. But most physicists don't believe the universe truly reaches these infinities. Instead, they see them as signposts, pointing toward new physics waiting beyond our current view. A gentle way to picture this is to think of space-time as a landscape drawn on a flexible rubber sheet. When you place a heavy ball, a planet or a star, on the sheet, it curves. The heavier the object, the deeper the dip. But what if the ball were impossibly heavy? The dip would stretch lower and lower until the sheet tore. That tear would be what we call a singularity. The infinity here is simply our way of saying, the rubber sheet isn't enough. We need a new material. Einstein himself was wary of infinities. To him, a physical theory that predicted such extremes was a sign that it was incomplete. His equations could describe how the sheet bends, but not what happens when it rips. Later, physicists like Stephen Hawking and Roger Penrose proved that, according to general relativity, those tears, those singularities, aren't just mathematical curiosities, they're inevitable. Wherever gravity grows too dense, the rhythm of space-time falters. Yet even those great minds suspected something was missing. Quantum mechanics, which governs the tiniest parts of the universe, teaches us that nothing is truly sharp or exact. Everything wiggles, everything blurs. Electrons, photons, even the tiniest grains of matter have no fixed location, only a haze of possibilities. So perhaps some physicists thought singularities wouldn't be sharp points after all. Maybe under the quantum microscope the impossible would soften. You can think of it like paint spreading in water. The deeper colour at the centre may look solid from far away, but up close, it diffuses, every particle drifting, mingling, finding space to breathe. Infinity, then, could dissolve into something finite but incredibly dense. A blur rather than a point, a shimmer rather than a wall. This idea comforts many scientists, not because it solves everything, but because it restores gentleness to the cosmos. A universe filled with infinities feels unlivable, too abrupt and cruel. But a universe that blurs its edges feels more human, a place where even the extremes have a little softness. In that sense, quantum theory doesn't fight infinity, it soothes it. Still, the temptation to believe in true infinities lingers. They have a strange pull, like standing at the edge of a cliff and gazing at the horizon, knowing it continues beyond sight. We are creatures drawn to boundaries, to the edges of maps. Infinity appeals to us because it mirrors something within, that restless wish to go farther, to understand completely, even when understanding fails. But infinity is not an answer. It's a mirror showing the outline of our ignorance. Each time science reaches it, we learn to look deeper, to invent new tools, new languages. Newton's laws gave way to Einstein's geometry, which in turn now bows to quantum theory. Each layer peels back another, never reaching the core, because perhaps there is no core, only an ever-deepening pattern. There's a quiet beauty in that too. The idea that our search will never end might sound frustrating, but it also means wonder will never run out. Infinity, once seen as a terrifying abyss, becomes a promise, not of endless failure, but of endless discovery. Like the ocean's horizon, it recedes only to keep us sailing. So the next time you hear scientists speak of infinite density or infinite expansion, remember, they're not describing reality itself, but the trembling edge of their own knowledge. The universe, in its wisdom, is kinder than infinity. It bends, but it does not break. It reaches the edge, then paints over it with a softer brush. And if we follow the trail of that brush a little further, we find ourselves entering the realm of a new physics, a place where gravity and quantum ripples mingle, where the sharp points of singularity turn into waves, where the impossible begins to blur. There, perhaps, infinity isn't the end of understanding, but the beginning of something gentler. If you've ever dropped a single drop of ink into a glass of water, you've seen what physicists mean when they talk about the gentleness of quantum nature. At first, the ink is dense and distinct, a perfect shape falling through clear stillness. But within seconds, its edges soften. The drop unfurls, swirling into filaments and clouds until it becomes part of the water itself. What was once sharp is now seamless. That is what the universe may do at its limits. It blurs. In the classical world, the one ruled by Einstein's geometry and Newton's certainty, things are smooth and predictable. You can measure a position, a speed, a path. But the quantum world, the one that hums beneath the surface, refuses such precision. Nothing at its core stands still long enough to be perfectly defined. Matter vibrates. Light ripples. Even empty space flickers with possibilities. The quantum world is made not of stillness, but of movement too subtle to see. When we look at a singularity, the supposed point of infinite density inside a black hole or at the birth of the cosmos, we're using equations that expect reality to be sharp and continuous. Those equations try to force the universe into a perfect dot. But quantum mechanics whispers that nature doesn't do dots. Everything spreads. Everything exists as a wave, a soft presence extending through possibility. If we could look closely enough at the heart of a singularity, we might not find a point at all. We might find a shimmer, a region of extraordinary density where time and space flow together like ink in water, impossible to separate. Physicists sometimes call this smoothing effect a quantum smear. It's a comforting phrase, almost domestic, as though the universe were gently wiping away the harsh lines drawn by our mathematics. In that view, The end of time at a singularity isn't a cliff where reality falls apart, but a place where the old rules melt and new ones begin to form. The sharp edge becomes a transition, not an annihilation. One way scientists imagine this transition is through the idea of quantum geometry, the notion that space itself has a fine, woven structure, like the threads in fabric. It's called loop quantum gravity, and in it, the smooth surface of space-time is replaced by tiny loops of energy that weave together to form reality. These loops are unimaginably small, far beyond the reach of any microscope, smaller than a fraction of a trillionth of a meter, yet they make up the texture of existence. In that picture, a singularity cannot form because the loops can't collapse past a certain point. They push back just as fabric resists being torn. Another picture comes from string theory, which imagines the universe built not from points or loops, but from one-dimensional strings. Tiny vibrating threads of energy, each humming with its own note. If matter and energy are melodies, then these strings are their instruments. When gravity crushes matter toward infinite density, the strings begin to vibrate wildly, spreading the energy outward in higher dimensions. The impossible sharpness of a singularity becomes a thicket of motion. The music doesn't end, it just shifts beyond our hearing. None of these theories are proven, but they share a comforting intuition. Nature does not like infinities. Just as sound cannot rise beyond a certain pitch without breaking into noise, reality seems to find ways to soften extremes. It never allows absolute zero or absolute compression, never true stillness or true chaos. At its deepest level, the universe is resilient, elastic, forgiving. This idea of quantum softness doesn't just change our picture of physics, it changes how we imagine the end of things. The Big Bang, for instance, may not have been a singular moment of birth, but a bounce, the rebound of a previous universe that had collapsed before ours began. Inside that rebound, quantum geometry could have blurred the singularity, preventing destruction and allowing time to turn smoothly from contraction to expansion. The universe, in this view, doesn't die. It transforms. Its heartbeat never stops. It only changes rhythm. It's humbling to think that something as abstract as a wave function, a mathematical description of how possibilities spread, might be the reason time itself doesn't tear apart. But that's what the equations suggest. Every atom, every photon, every particle we know exists as both a thing and a probability. Nothing in the quantum world is ever entirely here or there. It always hovers, undecided, until interaction gives it definition. When gravity becomes too strong, perhaps time itself behaves this way, hesitating between states, never choosing one final form. And maybe that hesitation is what keeps the universe alive. At the larger scales, time feels linear, sunrise to sunset, life to death. But beneath, at the quantum level, time may flicker like a candle in wind, constantly rewriting itself. Every instant you experience may be stitched together from countless microscopic fluctuations, moments of uncertainty resolving just long enough for you to call them now. If that's true, then the end of time is not a sudden stop, but the fading of that stitching, the soft unraveling of the fabric that lets one moment become the next. At the edge of a black hole, where gravity bends every path inward, those stitches stretch beyond recognition. Yet even there, the quantum hum persists, murmuring beneath the roar of collapse. The universe refuses silence. There's a strange tenderness in that thought, that even in its darkest places, reality keeps moving, keeps trembling, keeps singing. What we call endings may only be places where the universe pauses to take a breath. Perhaps the Big Bang, the Big Crunch, and every black hole in between are just notes in an infinite oscillating chord. The song changes, but the music never ends. And so, the idea of a quantum smear is not just a technical fix for broken math. It's a lesson in humility, a reminder that nature never truly deals in absolutes. Every boundary we find eventually blurs, every rule we write dissolves at its edge, and yet the universe continues smoothly on, never faltering. It teaches us that softness can hold structure, that even uncertainty can be steady. As we follow this thread of softness, the story opens toward a new question. If motion and time themselves can blur into geometry, what remains when the movement stops? Can the universe still exist without ticking seconds, without change? What if reality itself rests not on motion, but on shape? Imagine the universe asleep. No stars are born, no planets spin, no seconds fall like grains of sand. There is no before or after, only stillness, vast and weightless, like the quiet between breaths. It's a strange image, because we are used to thinking of the universe as endlessly active. Galaxies colliding, atoms trembling, light racing through the dark. Yet some physicists believe that beyond all this motion, there may lie a deeper layer of existence, one in which reality itself is not ruled by movement, but by form. This is the idea behind what some thinkers call geometry without motion. It sounds abstract, but it can be felt in something as simple as a moment of silence after a long song. The music ends, but the room still holds its shape. The sound fades, but the walls and air remain. In the same way, the universe may have a structure that continues even if the rhythm of time stops. To understand this, imagine space and time as a single surface, a fabric woven from both direction and duration. In Einstein's picture, that fabric curves around stars and planets, giving rise to gravity. The more massive something is, the deeper the curve it makes. Everything moves because of those curves, like marbles rolling on a soft sheet. But what if the sheet itself could exist even without anything rolling across it? What if, beneath the flow of seconds, there was a pattern, a geometry, that simply is without needing to change? This idea has roots in the work of a physicist named Brett McInnes, who explored what he called timeless geometric laws. In his vision, the early universe may have been shaped not like a point or a sphere, but like a torus, a ring, or a donut. A shape with no edges, no beginning, and no end. If you travel around it, you never encounter a boundary. Every path loops back on itself. It is the simplest possible form of endlessness. In that geometry, time could behave differently from the way we experience it now. Instead of stretching forward like a line, it could fold into itself, looping in patterns of symmetry. There would be no sharp distinction between start and finish, only a continuous curvature, a closed rhythm that always returns home. It's an image both mathematical and strangely comforting, a universe that never began and never truly ends, just turns itself over and over like a sleeping wave. When you think of a torus, picture not the pastry but the gentle orbit of something steady, a halo of energy swirling around emptiness, or the ring of light that sometimes appears when sunlight meets mist. It's the shape of balance, of continuity, and in McInnes's work, this shape hinted that the universe might obey laws that don't rely on time at all. These are not the dynamic laws of physics we usually use, laws that say how things move, how they accelerate, how they change, but geometric laws describing what is, not what happens. In such a world, reality would not need a clock to exist. There would be no ticking seconds, no unfolding history, only the quiet symmetry of being. Movement would still be possible, but not essential. It would emerge as a secondary feature, like ripples on a pond that already exists before anything touches it. This may sound otherworldly, but we can glimpse its meaning in our own experience. Think of a dancer frozen mid-step. The motion has stopped, yet the grace remains. The lines of the body, the balance of the limbs, they hold the memory of movement even in stillness. The geometry of that moment contains all the potential that came before and all that could follow. In a similar way, the universe might carry within its geometry the memory of its own motion, even when time itself stands still. Some physicists believe this timeless geometry may describe the true essence of the cosmos. When all processes cease, when stars burn out, when entropy reaches its maximum, when even black holes fade into faint whispers, the equations might no longer speak of change, but of structure. The universe would not end so much as it would rest in perfect balance. The cosmic story, after all its turbulence, would resolve into a final chord, held forever. It's not an entirely new idea. Ancient thinkers once described the heavens as the realm of pure form, where things exist not as events, but as patterns. Plato imagined an eternal geometry underlying the world, unchanging and perfect, while the physical realm merely reflected its shapes in fleeting, imperfect motion. Modern physics, in its own quiet way, seems to be rediscovering that intuition. Beneath the chaos of particles and fields, there may lie an abstract order, a geometry that doesn't evolve because it doesn't need to. This notion also offers a new way to think about what ending means. If the laws of motion describe the story of time, then geometric laws describe its background, the silent page on which the story is written. When time fades, that page doesn't vanish, it simply stops being written on. The shapes remain, even if the tale pauses. In that sense, the death of time might not be a tragedy at all, but a return to stillness, the universe exhaling, then holding its breath forever. It's tempting to imagine that in such a state, everything would feel frozen, lifeless. But perhaps stillness has its own kind of peace. A mountain range at dawn, unmoving yet alive with possibility. The moment before the orchestra begins to play. The breath you hold just before falling asleep. All of these are echoes of geometry without motion. Forms that exist independently of change, reminding us that calm and structure can coexist. If reality truly has this timeless layer, then time as we know it may be only one way of seeing. Like shadows cast by a solid shape, moments might be projections of something deeper, a geometry that doesn't flow, but simply is. In that sense, to reach the end of time might be to glimpse the world as it truly is, stripped of motion, stripped of noise, revealing the quiet architecture that holds everything together. When movement ends, only form remains. And perhaps that's not an ending, but the simplest kind of continuity, a shape that holds its place even when the song stops. As the trail of clues leads us gently into the next thought, we'll find that this idea of stillness is not the last word. For even if the universe rests, some believe it may one day stir again, not with a bang, but with a breath. Take a slow breath in. Feel the air fill your lungs, stretching you just slightly, then drift out again. Expansion and release. It's one of the oldest rhythms in the universe, a motion older than stars, older than life. When you breathe, you echo something vast. For a long time, scientists thought the cosmos might be doing the same, expanding and contracting, inhaling and exhaling through the ages. This is the idea of a cyclic universe, one that never truly begins or ends, but pulses like a living thing. The story we often tell of the cosmos starts with a single explosion, the Big Bang, but that's a simplification, a shorthand. The real picture, as many cosmologists describe it, is more like a ripple spreading across water. There was no bang in empty space because there was no space yet. The universe wasn't born in a place. Place was born in it. Time and space unfurled together as energy cooled and matter began to settle into patterns. But if space and time can unfold, perhaps they can fold again. Just as the expansion of the universe stretches galaxies apart, gravity still pulls gently against that stretching. If enough matter existed, that pull might one day overcome the expansion, drawing everything inward again. the galaxies that once fled from each other would slow, pause, and begin to fall back together. In that collapse, a mirror image of the Big Bang. Everything would heat and brighten, growing denser until the fabric of space curved back on itself. Some have called this the Big Crunch, a final exhalation drawn in reverse. It sounds tragic, but some theories suggest this inward rush would not be an end. When the collapse reaches its deepest point, quantum geometry, those loops and threads beneath space itself, could prevent a true singularity. Instead of tearing, the fabric would rebound, swelling outward once more. Time would continue through that turning point, perhaps without missing a beat. In that case, the Big Bang we know would not be the first breath, but the latest one, the midpoint in an infinite rhythm. To describe this rhythm, some scientists use an image both mathematical and poetic, the universe as a cosmic heart, contracting and expanding across eternity. Others picture it as a pendulum swinging between order and chaos, or a wave rising and falling through time. But maybe it's simplest to think of it as breathing, a long, slow inhale of creation followed by an exhale of rest. In this view, death and birth lose their sharp distinction. The end of one cosmos becomes the seed of the next. Ashes, energy, light, all feed the next beginning. There's something almost biological in it, a sense that the universe recycles itself the way a forest does, turning its fallen leaves into soil for future growth. The idea of cosmic rebirth has appeared in many traditions. Ancient Hindu texts describe an endless cycle of creation and dissolution, each cosmic age followed by another, like nights and days of Brahma, the great dreamer. The Stoics of ancient Greece imagine the universe igniting and cooling in infinite succession. Even modern science, in its quiet language of equations, carries whispers of that same rhythm. When physicists study the early moments of expansion, they find signs that the universe may have inherited patterns, tiny ripples in temperature and density, from something that came before. If that's true, then the Big Bang wasn't a singular beginning, but a transition, the latest movement in a symphony too long for us to hear in full. Each cosmic cycle would leave traces, like faint echoes in the background radiation still washing over us from the early universe. Those ripples might be the afterimage of an earlier breath, preserved in the faint static between stars. The beauty of this idea lies not only in its symmetry, but in its tenderness. A universe that bounces is one that refuses to let go completely. Even as it collapses, it stores potential, a coiled spring of possibility waiting to unfold again. In quantum models, this potential isn't mystical but physical. As matter compresses beyond comprehension, the same uncertainty that governs subatomic particles begins to dominate the whole cosmos. Space can't shrink forever. Its smallest loops of geometry resist, much like atoms resist being crushed into nothing. When that resistance peaks, it turns collapse into expansion. The universe breathes out. What would that moment look like? The instant between collapse and rebirth? There might be no way to picture it, because the normal rules of cause and effect wouldn't apply. Time itself could lose meaning, blurring in the same way sound blurs in an echoing hall. But perhaps, if consciousness could exist through such a transition, it would feel not like destruction, but like awakening, as though the universe, exhausted by its long fall, suddenly remembered how to move again. This concept, called the Big Bounce, carries a quiet optimism. It tells us that endings aren't absolute, that even in the deepest collapse the seeds of renewal remain. When physicists run their models backward, the equation suggests that our universe's expansion may have been born not from nothing, but from a compressed state of an earlier cosmos. The pattern of cycles may go on forever, expansion following contraction like heartbeat after heartbeat. Of course, this is still speculation. No one can peer beyond the veil of the Big Bang to see what came before. The evidence may always remain faint, a few subtle fingerprints on the cosmic microwave background, a few patterns in the distribution of galaxies. Yet the very possibility that the universe could have a past beyond its supposed beginning invites a kind of cosmic humility. It reminds us that what we call the start may only be a doorway in an infinite corridor. And maybe that's the gentlest message hidden in these models. Everything breathes. Galaxies, stars, even atoms. They expand, contract, and expand again. You do the same every minute of your life, and when your breath ends, others will begin, drawing from the same air. In that sense, you and the universe share the same rhythm, the quiet exchange between fullness and emptiness, between presence and release. The big bang, the big crunch, the big bounce. These are not separate stories, but the same story told in different tempos. The universe may not have a single birth or death, only infinite variations of the same cosmic inhale. And just as you don't think of every breath as a beginning, the cosmos may not either. It simply continues, rhythm upon rhythm, the melody too vast for us to hear all at once. As we drift further into the story, this rhythm of breath will soften into something subtler, the slow loss of time's direction, the fading of the arrow we take for granted. For even if the universe continues to breathe one day, its motions may quiet until all arrows point nowhere and duration itself begins to dissolve into stillness. Think of your morning coffee cooling on the table. You pour it steaming and fragrant, and a few minutes later it's gone lukewarm, calm and ordinary. It never reheats itself, never gathers back its energy and begins to steam again. Every day, everywhere, things move from order to disorder, from warmth to chill, from structure to scattering. That's what we call the arrow of time, the sense that the universe moves forward, not backward. Yet in the language of physics, this arrow is more of an illusion than a rule. Most of the laws that describe nature don't care about direction. If you film two planets orbiting each other and then play it backward, this scene still follows the same equations. Motion, gravity, even the dance of atoms look almost identical in reverse. Time, at the fundamental level, has no preference for past or future, and yet we, living things built from fragile complexity, always experience it, flowing one way. Why? The answer begins with a word that sounds cold but hides quiet poetry: entropy. In simple terms, entropy measures how spread out or disordered energy has become. When your coffee cools, heat flows from the hot liquid to the cooler air. The total energy stays the same, but it becomes less organised, less able to do work. The universe is a master of conservation, but not of tidiness. It keeps everything but rearranges it into messier and messier forms. Entropy gives time its direction because it's the one thing that always increases. A broken cup won't leap back together. Smoke won't gather itself back into a candle flame. There are countless ways for things to fall apart and only a few ways for them to stay ordered. The odds alone push everything toward disorder. If the universe were a house, entropy would be its gentle, unstoppable dust. It's tempting to think of this as a law of decay, something gloomy or final. But entropy is also the reason complexity can exist at all. Stars shine because they burn fuel, turning concentrated energy into diffuse light and heat. Life itself depends on imbalance. Every heartbeat and thought powered by the flow of energy from order to disorder. In a very literal way, the arrow of time is the pulse of existence. Yet physicists still find the arrow mysterious. Why does entropy increase? Or rather, why did the universe start in such an improbably low state of disorder? If it began already messy, there would be no direction for entropy to climb, and time might not seem to flow at all. The very fact that we feel time moving forward suggests that the cosmos began improbably tidy, a hot, smooth, perfectly balanced beginning. Out of that symmetry, the smallest imperfections grew. Galaxies forming, stars igniting, planets coalescing, and eventually us sitting beside our cooling coffee. Roger Penrose once pointed out that this initial tidiness is one of the great riddles of cosmology. According to him, the early universe had almost no gravitational clumping, an incredibly precise starting condition. If you could shuffle all the possible ways matter might have been arranged, the one that actually happened would be unimaginably rare. It's as if the cosmos began by balancing an ocean of sand so evenly that every grain was exactly level. From that perfection came every future imperfection. There's something paradoxical about that. Disorder is what creates the flow of time, but order is what allowed disorder to begin. Without the unlikely symmetry of the early cosmos, there would be no arrow, no direction, no evolution. The universe might still exist, but frozen, a perfect equation, lifeless and still. Some scientists have tried to redefine the arrow using new language, something called thermal time. In that view, time is not an external stream, but an emergent rhythm that arises whenever matter has heat to exchange. You could think of it as the universe's internal heartbeat. Each flow of warmth, each movement toward balance marks a pulse. When there's no imbalance left, when everything has reached the same quiet temperature, the pulse stops. Time, in that sense, is not something we move through, but something matter does while it relaxes. There's an odd comfort in this. It means that the arrow of time is not imposed on us from outside, but born from the same tendency we feel in ourselves, the drift toward rest. Every sunset, every aging leaf, every sigh follows the same natural impulse, the release of energy into the greater calm. The direction of time is the direction of unwinding. Still, there's a melancholy hidden in the thought. If entropy forever increases, the universe must one day reach a state where it can no longer change. Physicists call this heat death, a future where all stars burn out, all differences of temperature vanish, and every process grinds to stillness. In that remote age, there will be no arrow, no before or after, just a quiet sea of particles moving without purpose, like dust motes in a beam of eternal twilight. But for now, entropy's rise gives us the story of everything. It's the reason light travels from stars to eyes, the reason winds move across oceans, the reason hearts can beat. Without the tendency toward disorder, there could be no growth, no learning, no life. It's strange to realize that chaos and creation share the same origin, that the same rule that ends all things also allows them to begin. Perhaps the arrow of time isn't a law at all, but a habit, the universe's way of sighing. And habits can fade. When the differences even out, when every candle burns down and every echo fades, that habit will dissolve too. What will remain is not the arrow, but the page on which it was drawn, a geometry so smooth that even direction has no meaning. For now, though, the arrow still flies. You can see it in every falling drop of rain, in every line written, in every fading heartbeat. And maybe that's why moments feel precious, because they are literally the rarest kind of order, fleeting arrangements of improbability against the tide. Time's arrow may be born from disorder, but what we love most about life are those brief reversals, those delicate pockets of pattern that bloom before vanishing. As we drift further into the story, that arrow will bend towards stillness. We'll follow it into the far future, where the ticking of clocks loses its rhythm and the very idea of duration begins to fade. There, a different voice, that of Penrose himself, will offer a startling vision, that when all scales and measures dissolve, the universe may yet find a way to begin again. Picture a quiet room filled with clocks. Some tick loudly, others whisper, each marking a slightly different rhythm. At first the sound is steady, comforting, a heartbeat of the world. But as you listen longer, the rhythms drift apart. One clock slows, another rushes ahead. Then little by little the ticking fades. What happens when the last sound stops? When the world has no beat to measure itself by? That is the question at the heart of Roger Penrose's vision of time. For him, the end of the universe is not a fiery apocalypse, but a soft hush, a place where the very idea of duration dissolves. Time, he suggests, can lose its meaning not through destruction, but through the loss of everything that once kept rhythm. To understand how this happens, we can go back to the beginning, or rather, the beginning that wasn't truly one. In the early universe, everything was so hot, so tightly packed, that the ordinary structures we use to measure time simply didn't exist. There were no stars to rise and set, no atoms to vibrate in regular patterns, no pendulums or pulses. Even the tiniest particles like electrons or quarks were weightless, pure motion without fixed form. In that chaos, you could not have counted seconds even if you'd wanted to. Time was present, but it had nothing to hold on to. Penrose calls this strange condition a scale-free state, a universe without a ruler, without a clock. It's like being lost in fog with no horizon, where distance and direction lose all meaning. According to him, the far future of the cosmos will resemble that same fog. As entropy rises and energy spreads out, all distinctions fade. Stars will exhaust their fuel. Black holes will evaporate into faint whispers of radiation, and what remains will be a thin sea of light, particles travelling endlessly, but without anything to compare their motion against. When that happens, the universe's sense of scale, its ability to tell small from large, slow from fast, will vanish. With no masses left, there will be no ticking heartbeats, no oscillations, no measurable intervals. If there are no clocks, Penrose once said, then there is no time. It sounds paradoxical, but it follows from the way physics defines measurement. Time in every experiment is not something that exists by itself. It's something we infer by observing change. A pendulum swings, a particle decays, a planet circles the sun. From these motions we build the illusion of flow. But if every process ends, what remains to mark duration? The hands on all the cosmic clocks will slow, then stop, not because something breaks, but because there's nothing left to move. In his book Cycles of Time, Penrose imagines this not as an end, but as a transformation. He calls it conformal cyclic cosmology, though we can describe it more softly as the idea that endings and beginnings share the same face. In his model, the far future, a universe of infinite expansion and fading energy, becomes indistinguishable from the early universe that began our own. The two eras are related not by continuity of matter, but by continuity of shape. Both are scale-free, both empty of mass, both timeless in the same way. To picture it, imagine stretching a balloon until its surface becomes so vast that it seems flat. Now imagine that same surface, when viewed from another perspective, as the small curved seed of a new balloon just beginning to inflate. The distant future of one universe folds seamlessly into the birth of another. From our limited view, these are two different epochs, separated by unimaginable ages. But from the perspective of geometry, the universe's quiet architecture, they may be one and the same. Penrose's idea is radical because it reframes death as renewal. The slayer of time, as he once called entropy, becomes its saviour. When all order dissolves, when every trace of structure disappears, the cosmos achieves a kind of purity, a blank canvas upon which a new pattern can arise. Out of that stillness, time might start again, as it once did before. The thought carries both wonder and humility. It suggests that time is not a river flowing endlessly in one direction, but a loop of fading and returning, of memory and forgetting. Each universe, like each life, inherits only the faintest traces of what came before, not the details, but the tone, the resonance. If the background radiation we observe today is the fading echo of the last cosmic breath, then perhaps some distant civilization in the next cycle will hear ours, woven faintly into their own skies. This idea also reshapes how we think about ourselves. We spend our lives measuring time, birthdays, seasons, minutes between appointments, as though those numbers were solid, But Penrose reminds us that clocks work only because the universe is uneven, because there are gradients of energy, differences to count. Without contrast, there's no motion, and without motion, no measure. In the most profound sense, time exists only because imbalance exists. That means the universe's perfection, the final, featureless calm it moves toward, will also be its silence. Every clock will forget its measure because there will be nothing left to compare against. Duration will have no reference. Like a song stretched to infinity, every note will blend into the next until melody becomes hum, and hum becomes nothing. And yet, within that silence, Penrose hears potential. He suggests that the geometry of this final state, smooth, empty, luminous, naturally allows a new phase to emerge. When the last remnants of matter lose their mass, they no longer distinguish between infinite expansion and a fresh beginning. Time, in that moment, may fold over itself, turning death into dawn. It's a thought that feels both scientific and spiritual, as if the cosmos were practicing a kind of reincarnation. The universe dies not in darkness, but in a light too uniform to cast shadows. It becomes timeless not by ending, but by shedding all memory of change. As we stand somewhere in the middle of its great journey, between the first pulse and the last, we can feel gratitude for the imbalance that keeps our clocks ticking. Every heartbeat, every rotation of the Earth, every sunrise is part of the universe's temporary disorder, the gentle noise that lets time be heard. In the next step of our journey, we'll explore what happens if this fading continues, not just for matter and motion, but for time's very texture. When the ticking slows and the distinction between past and future dissolves completely, there, the story of time will stop moving forward and begin turning inward, towards stillness and reflection. Imagine holding a leaf in your hand on a breezy day. You let it go, and it drifts softly through the air, carried by invisible currents. Sometimes it glides gently, sometimes it spins, tilting its fragile surface toward the sky. You can't see the wind that moves it, only the leaf's graceful response. Now, imagine that the leaf is our universe, thin, delicate, and drifting through something larger we cannot touch or see. This is one of the gentlest metaphors scientists use to describe the strange idea of higher dimensions. They call our universe a brain, short for membrane, a four-dimensional sheet floating in a wider, higher dimensional space. Everything we know, from galaxies to the flicker of your thoughts, lies on this sheet. We cannot step off it, cannot look behind it. Yet the universe, as the equation suggests, may be moving through something beyond itself, a kind of higher dimensional wind. Most of the time, this invisible motion feels calm. We, like caterpillars crawling along the leaf, think the world beneath us is all there is. We measure time by our steps, the texture of the surface beneath our feet, the pattern of veins that mark our path. But if the leaf begins to bend or twist, if the wind shifts, the world around us might change in ways we can't explain. What feels like acceleration, expansion, or even the fading of time might simply be the leaf, our universe, curving gently through that unseen air. To the astronomers who map the sky, the universe seems to be expanding faster and faster, as though some invisible energy were stretching space itself. They call it dark energy, but the name hides more than it reveals. No one knows what it is or where it comes from. Some imagine it as a property of space, others as a kind of pressure pushing from beyond. But if you think of our universe as a leaf, you might picture dark energy as the wind, not something in space, but something around it, folding and turning the fabric of time itself. When this higher dimensional wind blows strongly, the motion of everything on the leaf changes. Distances stretch, galaxies drift farther apart. Light, travelling across the cosmos, seems to slow and fade. To us, it looks like time itself is changing speed. But perhaps time isn't slowing or speeding. Perhaps it's bending, curling into new directions we can't yet imagine. Some scientists have tried to describe this mathematically, but the equations are dizzying. Instead, we can think of it as the moment a flag flutters in the breeze. To someone standing far away, the flag's ripples might look like waves running along its surface. But those waves are not truly separate from the air that stirs them. In the same way, our universe might ripple with what we call time, only because it's being stirred by something greater, a breath from dimensions beyond our own. If that's true, then the mystery of cosmic acceleration might not be about energy at all. It could be about geometry. The universe may be folding, its dimensions shifting subtly so that time, the steady rhythm we take for granted, begins to behave more like space. The distinction between before and after might slowly dissolve, leaving behind a continuum where time spreads out like a landscape rather than flowing like a river. In that strange future, motion as we know it would slow. Processes would freeze, not because they are destroyed, but because their meaning would vanish. When time turns into space, every moment becomes equally real, all events existing side by side like colours fixed in a painting. The universe, once a song, becomes a mural. It's hard to picture such a thing without fear. After all, we are creatures of motion. We depend on sequence, on heartbeat and breath, on cause and effect. A world without time sounds like a world without life. But maybe that's not the right way to see it. Maybe it's not that time dies. Maybe it simply changes shape. The flowing current becomes still water. The melody becomes harmony. In that stillness, everything that ever was remains, woven into the quiet geometry of existence. This transformation, if it happens, would not be sudden. It would unfold slowly, like twilight softening into night. The light of distant galaxies would fade first, their motion stretching into silence. Then the smaller rhythms would follow. The ticking of atoms, the spinning of electrons, the flicker of radiation. Each would slow, not because something stops them, but because the difference between one tick and the next becomes meaningless. Duration itself would fade, and with it the sensation of change. It's possible that dark energy is already part of this process. Not a force tearing the universe apart, but a whisper of transformation. As the cosmos expands, it thins out, cools and smooths. Its texture grows faint, like a leaf growing transparent in sunlight. The boundaries between space and time blur. What we call acceleration may be the first sign that time, in its old sense, is beginning to curl into space, that the direction we once followed so faithfully is slowly folding over itself. It's a quiet and humbling thought. The universe may not be running away from us, but folding around us, rearranging itself into a form we can't yet perceive. We may be like creatures walking along that drifting leaf, unaware that the wind beneath us has changed direction. And if that's true, then perhaps even the end of time is not a catastrophe, but an act of grace, a turning inward of the universe, like a dancer slowing her motion until movement becomes posture. The song of creation doesn't end, it simply holds its final note, long and low, until it becomes part of the background hum. The next step of our journey will follow that hum into a vision even stranger, where the universe itself becomes a hologram of information, and where the boundaries of space and time may dissolve completely, leaving only patterns, reflections, and the faint memory of order. Close your eyes for a moment and imagine holding a small, square piece of glass. When light strikes it from the right angle, a picture floats within it, a three-dimensional image hovering in mid-air. Tilt the glass, and the image shimmers, changing perspective as though you were looking through a window into another world. That illusion is a hologram, depth created from surface, space born from pattern. Now, imagine that the entire universe might work the same way. In modern physics, Some thinkers believe that the three-dimensional world we experience, with its stars, its galaxies, and its sense of distance, could actually be a projection from something deeper and simpler. The concept is called the holographic principle, but you can think of it as nature's way of painting with light. Every event that happens inside the universe could be recorded, like a subtle interference pattern on a vast invisible surface that surrounds it. From that surface, the illusion of space, and even time could arise. It's a strange idea, but strangely elegant. If true, it means that the motion of planets, the burning of stars, even the feeling of your hand resting on a table, might all be expressions of information, patterns etched into the cosmic boundary. The world we see would not be fake, but rather a translation, like music performed from notes on a page. The page holds the instructions, the sound is what we live inside. To picture this softly, imagine that the universe is a pond, and every drop of rain that falls on it creates ripples. Those ripples overlap and form patterns that tell the story of every drop, where it fell, how fast, how deep. Even if the ripples fade, their memory remains encoded in the surface of the pond. The holographic idea says something similar, that the edge of the universe, perhaps its outer boundary, perhaps even the surface of black holes, holds the memory of everything that has ever happened. The interior is a reflection of that stored information. In this view, what we call space may be nothing more than the way our minds interpret the relationships between these patterns. Space feels continuous because information is organized smoothly. Time feels like a flow because the patterns update in a sequence we experience as before and after. But when order breaks down, when matter collapses into chaos, or when the geometry of the universe melts under its own weight, those distinctions begin to blur. Think of ice melting into water. The solid lattice that once gave it structure disappears, and with it, the clear boundaries between one shape and another. The water still exists, but it has no fixed form. In the same way, when the structure of space-time breaks down, the dimensions we depend on, length, width, height, and time, lose their rigidity. They dissolve into something formless yet still real, something that no longer distinguishes between motion and rest. This happens most vividly inside collapsing stars. As gravity tightens its grip, the order that defines space and time starts to fail. According to the equations, the star's material collapses into a region so dense that geometry itself cannot keep up. The clocks, at least the idea of clocks, begin to spin wildly. Seconds stretch, minutes lose meaning, and the story of cause and effect begins to tangle. From the outside, it looks as though the star's fall slows forever, frozen at the edge of invisibility. From within, everything happens all at once. It's as though time has melted into space, becoming a single, timeless volume of information. The holographic principle offers a way to describe this without invoking impossible infinities. It says that as the star collapses, the information about everything it contains, every atom, every photon, is not lost but spread across the surface that forms around it. That surface becomes the black hole's event horizon, a cosmic archive. The star disappears from view, but its story remains written pixel by pixel on the boundary that marks its absence. The hologram endures even when the object is gone. Seen this way, the death of a star is not destruction but transformation, the conversion of depth into surface, of motion into pattern. And if that's true on the scale of stars, it might be true for the universe itself. The grand stage of space and time could be the projection of a deeper order, one that exists outside what we can measure. It's almost too beautiful to be coincidence, that the same mathematics describing black holes also hints that all of space-time behaves holographically. The universe may not be an empty void filled with objects, but a vast symphony of correlations. Each particle, each burst of light, each moment reflects information stored somewhere else. The more we look, the more we find echoes rather than edges, patterns repeating at every scale. But even that beauty has limits. For a hologram to work, the interference pattern must be precise, each line perfectly arranged. When the order melts, when the lines blur, the image dissolves. It's still there in principle, but its meaning is gone. In the same way, when the universe loses coherence, through collapse, through decay, through the slow unraveling of entropy, the relationships that define space and time may lose definition. Reality doesn't end. It simply forgets how to separate one place from another, one moment from the next. If you've ever watched mist erase the landscape at dawn, you know the feeling. Mountains fade first, then trees, then even the path at your feet. Nothing has vanished, yet everything is gone. That's what the melting of dimensions might be like. A soft disappearance of distinction. When order melts, so does meaning. The story doesn't end, it just becomes unreadable. And perhaps that's the ultimate secret of the holographic universe. What we call space and time are not the foundation but the interpretation, a temporary translation of something deeper, something that doesn't need dimension to exist. When the pattern holds, we see stars and galaxies. When it fades, we see nothing. Not because nothing remains, but because the melody has become silence. As we drift further into the story, we'll linger on what happens in that silence, when even causality itself begins to lose its shape. If the universe is a hologram, then what happens when the light that projects it flickers? What becomes of before and after, of reason and result? The next part of our journey will follow that question, into a place where cause and effect no longer stand in line, and time's choreography becomes a swirl of overlapping steps. Imagine standing in a quiet canyon and calling out. You wait, and a moment later your voice comes back to you as an echo. It's an experience so ordinary we rarely think about what it means. 'Cause first, then effect. You speak, then sound returns. The sequence feels sacred, the foundation of how we make sense of anything. But what if one day you called out and heard the echo before your voice? You would freeze, confused, because your mind, built to follow order, cannot easily imagine its reversal. Yet at the deepest levels of reality, nature sometimes behaves as if the echo can arrive before the shout. This strange possibility belongs to a concept called indefinite causal order. It arises not from imagination, but from the mathematics of quantum mechanics, the branch of physics that governs the smallest things. At that scale, events are no longer crisp or clearly sequenced. Instead, they exist in a kind of shimmering ambiguity where before and after can overlap. Two events can influence each other simultaneously, or even in an order that depends on how you look. Cause and effect stop being a line and become a web. To soften the idea, think of it like a dance. In ordinary life, one dancer leads and the other follows. Every movement depends on the previous step. But in quantum reality, both dancers move at once, adjusting to each other in a blur of mutual response. The choreography remains graceful, but there is no leader, no follower. Each step exists because of the other. Scientists have even built experiments to glimpse this strangeness. Using beams of light and devices that split and recombine them, they've shown that under special conditions, the order of events can indeed become uncertain. It's as if a photon, a single particle of light, can decide which path it took only after it arrives. The universe at its smallest scales is less like a line of dominoes and more like a circle of whispers, each event completing the others. This challenges one of our oldest assumptions, that causality is the bedrock of reality. For centuries we've believed that everything happens because something made it happen. It's how we think, how we build machines, how we understand stories. Even the word because carries that trust. Yet if cause and effect can blend, Perhaps the universe isn't built on order after all, but on relationships. Maybe it doesn't need a strict sequence to remain whole. In the heart of a black hole, or near the beginning of the universe, this blending might already be happening. There, gravity is so strong and quantum effects so wild that time itself loses its linear shape. What we call the past and the future could fold into one another like layers of silk. The laws of physics don't forbid it. They simply fall silent, unable to separate one event from the next. To picture this gently, think of a river approaching the sea. Far upstream, the current is strong and directed. Every drop of water knows where it's going. But near the delta, the current slows and spreads into a maze of streams and eddies. Direction still exists, but only locally. The flow becomes self-entangled. Time may be doing something similar on the grander scales. Far from singularities, causality flows neatly. Near them, it meanders, blurring into itself. And if causality blurs, so too does meaning. Our memories depend on the idea that events follow one another. Without that order, even the idea of a story becomes fragile. Yet nature may not mind this loss. The universe does not need meaning to exist, only we do. To it, the web of cause and effect might be a single, simultaneous structure, all interactions existing together, not sequentially. What we experience as unfolding time may be our way of walking through that structure, one thread at a time. Some philosophers have wondered whether our own consciousness depends on causality, whether our sense of self comes from this orderly chain of moments. If the chain were broken, would awareness still make sense? Perhaps not as a sequence, but maybe as something more like harmony, a simultaneous blending of thoughts, memories, and possibilities. The mind, after all, does not experience every detail in strict order. When you recall a childhood memory, the past touches the present instantly. Causality loosens in small ways within you all the time. Maybe that's what the universe is doing too, remembering itself all at once. If time is the way reality tells its story, then causality is its grammar. Near the end of time, that grammar might dissolve, leaving a kind of poetry without punctuation, a field of meaning beyond sequence. The sentences remain, but they no longer follow one another. They coexist. In the holographic view we explored before, where the universe's information is stored on a vast surface, such coexistence makes sense. The hologram doesn't unfold in time, it simply is. Every point contains echoes of all others. If that's true, then the blurring of causality isn't an error but a glimpse of the universe's deeper nature. We're used to reading it line by line, but perhaps reality was written as a single page all along. It can be unsettling to imagine a world without before or after. We find comfort in progression, in the cause that explains the effect, in the clock that measures the moment. But if we listen quietly, there's also peace in the idea that nothing is ever truly first or last. Everything belongs to everything else. Every event depends on every other, as notes depend on each other to form a song. The melody of the cosmos may not have a starting note or a final one. It may simply exist, complete and continuous. As you breathe now, consider that even your breath is part of that harmony. The inhale causes the exhale, but also the other way around. One defines the other. Without both, there is neither. Perhaps that's what the universe is teaching us through its loosening of causality, that the most fundamental things are not separate but circular. The arrow we once thought pointed forward may simply be drawing a loop. If we follow that loop gently, we find ourselves back where all this began, not in theory but in feeling. A quiet recognition that the flow of time, the sequence of cause and effect, may not be the universe's foundation but its surface. Beneath it lies something slower, steadier, more complete, a timeless field where everything touches everything else. And as our quiet exploration turns toward the human side of this story, we'll carry that idea with us. Because if time and causality can dissolve into harmony, then maybe so can we, as beings of structure, story and rhythm, finding peace in the stillness beneath our own unfolding. If you've ever stood close to an orchestra as it warms up, you know the sound is chaos at first. Violins wander, flutes flutter, a single drum tests its echo in the hall. Then, almost imperceptibly, something happens. The separate sounds begin to cohere. Notes align, rhythm finds a pulse, and out of 100 scattered vibrations, a single melody emerges. That transformation from noise to harmony is what physicists mean when they say that time might be emergent. It isn't imposed from above like a ticking metronome. It arises from relationships, from structure, from the simple fact that things interact. In a completely empty universe, one with nothing to compare or change, the word before would have no meaning. You can't measure a pause when nothing can pause. But as soon as two particles meet, exchange a spark, share a vibration, the concept of sequence appears. This happens not just in matter, but in everything from the cosmos to your own thoughts. Time, in that sense, might not be the stage on which the universe performs. It might be the performance itself, produced by the orchestra of existence playing together. Scientists exploring the idea of emergent time sometimes use mathematical frameworks, but we can describe them more gently. Picture a room filled with countless metronomes. If they all begin ticking at random, the sound is confusing. Yet over time, the vibrations of the floor allow them to fall into step. Their movements synchronize. From chaos comes rhythm, and from rhythm the perception of flow. The universe, vast and ancient, could be doing the same thing. Its countless particles and forces slowly fall into patterns that create the illusion, perhaps even the reality of passing moments. This is how physicists like Carlo Rovelli, who studies loop quantum gravity, imagine time. Not as an independent stream, but as something woven from correlations. He sometimes calls it relational time, because it exists only through connection. When things interact, their states change relative to one another. That relative change becomes what we experience as time's progression. Without interaction, there is no reference, and without reference, no clock can tick. We can feel this principle in our daily lives. A single person, lost in perfect solitude, loses track of time. Minutes stretch or vanish. But in conversation, in work, in love, time sharpens again. Our sense of now depends on how many rhythms we're connected to, the hum of other hearts, the turning of the earth, the glow of sunrise. Time is the music that arises when enough instruments are playing, and when those instruments stop, so does the music. In physics, this happens when systems reach equilibrium, when every energy exchange is balanced, and no difference remains to drive change. At that point, time, at least in that region, no longer has direction. In human life, we experience softer echoes of this stillness, the hush that follows deep meditation, the weightless pause before sleep. The orchestra falls silent, but its harmony lingers in the air. This perspective changes how we might think about endings. If time depends on structure and interaction, then when structure collapses, time gently fades too. It doesn't slam shut, it quiets. The same way an orchestra's last note rings into the hall before dissolving, the universe may one day let its rhythm stretch into silence. Time will end not with a bang, but with a decrescendo. Even consciousness may follow this pattern. Neuroscientists sometimes describe awareness as a symphony of electrical rhythms, billions of neurons firing together in complex patterns. When those rhythms align, a sense of flow appears. Thoughts connect, memories link, identity takes shape. But when the synchronization falters, such as in sleep or deep anesthesia, that sense of flow loosens. The experience of time slows or stops altogether. The self, so sure of its continuity, turns out to be another emergent rhythm, another melody rising from countless moving parts. In that light, time is not a cosmic clock imposed upon us, but a song we participate in. We are not passengers carried by its current. We are musicians within its ensemble. Every heartbeat contributes a beat, every breath another measure. Even the smallest atom hums its part, vibrating at frequencies that define the structure of reality. The universe is a vast composition, and each of us is both listener and performer. But what happens when the music changes key? When structure fails and the instruments grow quiet? Then the symphony doesn't truly end, it transforms. The melody becomes harmony, the harmony becomes silence, and within that silence the potential for a new rhythm waits. This is how physicists imagine the boundary between existence and non-existence, not as a wall, but as a rest note in an endless score. You might feel this in the spaces between moments. When you pause to breathe and the noise of thought fades, time seems to widen. The second hand slows, the present thickens, and for a fleeting instant, the ordinary rush of cause and effect relaxes. That pause is not the absence of time, it's time returning to its source, the calm from which all rhythm arises. The more scientists study the universe, the more they find that complexity and order are intertwined with rhythm. Galaxies spin in gravitational dances, ecosystems pulse with growth and decay, even economic markets breathe in expansions and contractions. Wherever patterns form, time crystallizes. Wherever patterns dissolve, time softens again. The universe's most profound secret might be that existence and rhythm are the same thing said two ways. And so, the idea of emergent time isn't just a physical theory. It's a quiet invitation. It suggests that you are part of the very process by which moments come into being. When you think, when you love, when you observe, you contribute to the fabric of time itself. Each connection you make strengthens the symphony. Each kindness adds a note that keeps the melody going. But eventually, as with every orchestra, the instruments will rest. The cosmic music will fade back into stillness, not as failure, but as fulfillment, a return to the timeless foundation that gave rise to rhythm in the first place. The silence after the last note will contain all the notes that ever were and all the ones that could be again. Our path now carries us from this grand harmony to something more intimate, the reflection of cosmic stillness within the human heart. If time ends when structure dissolves, what does that mean for us? For living beings whose lives are shaped by structure itself? Perhaps the end of time is not a tragedy to fear, but a mirror of the peace we glimpse each night when we close our eyes and let our own inner symphony rest. Close your eyes and think of the quietest moment you've ever known. Maybe it was a night long after the city had gone to sleep, or a walk through winter woods when the air was so still it seemed even sound had frozen. In that hush, there's a feeling both haunting and peaceful. The sense that the world, for a heartbeat, has stopped moving. That feeling might be the smallest echo of what physicists mean when they talk about the end of time. And it might be what we, as living beings, brush against in the moment we call death. Throughout this journey, we've explored time as a rhythm, a melody woven by motion and change. But if time emerges from structure and interaction, then what happens when those structures dissolve? When the orchestra of matter falls silent, does the music of time fade too? For the universe, this might mean the cooling of stars, the end of motion, the soft settling of energy into stillness. For a human being, it might mean the final slowing of a heartbeat, the end of that small symphony of cells that kept rhythm with the cosmos. From one perspective, both are the same event, the return of movement to stillness, of sound to silence. We often imagine death as a boundary, but perhaps it's more like a blending. The pulse of life merges with the wider calm of the universe, just as a wave merges back into the ocean. Time, for that individual pattern of existence, ceases to flow. Yet the ocean of time itself, the greater field of relationships that gave rise to the wave, continues to shimmer quietly in the distance. It helps to remember that every living thing carries within it a map of cosmic processes. Your body is made of atoms forged in ancient stars, each nucleus once part of an explosion billions of years ago. When those atoms were scattered into space, they carried with them the possibility of life, the potential for time to organise itself into memory and thought. In a sense, your heartbeat is the universe remembering how to keep rhythm, and when that rhythm stops, the material doesn't vanish, it simply returns to the greater song, its notes dissolved but still present in the score. Seen this way, the end of life isn't the erasure of time, but the moment when personal time melts into the timeless, the way a single candle's flame disappears only because it joins the light of dawn. The sequence of minutes and days that once defined your story becomes part of a quieter continuity. It's not nothingness, it's completion. Some scientists and philosophers have speculated that consciousness itself might be tied to time's flow, that awareness is what happens when matter looks at its own unfolding, moment by moment. In that case, the fading of consciousness at death might not be an abrupt cut-off, but a kind of smoothing. The clear boundary between past and future dissolves, and the mind's sense of sequence softens into something broader, an eternal present that no longer measures itself. It's impossible to prove, but strangely the physics of the cosmos and the poetry of the soul seem to lean toward the same image. Time returning to stillness as gently as breath leaving the body. There's a deep humility in realizing that the processes that end a life are the same ones that end stars. When a star exhausts its fuel, it doesn't vanish instantly. It swells, shimmers, and slowly releases its energy into space, feeding the birth of new stars and planets. In the same way, when a living being dies, its heat, its motion, its matter, all spread outward, nourishing new forms. Nothing truly ends, it only changes its rhythm. Death, in that sense, is the universe exhaling through us. If we could stand outside of time, the line between living and non-living might blur entirely. We'd see not individuals beginning and ending, but patterns rising and fading within one continuous field. The same physics that governs the birth of galaxies governs the beating of a heart. The same equations that describe collapse and expansion also describe the inhale and exhale of lungs. In every moment of existence, the personal and the cosmic mirror each other. You can even feel this on a small scale in the way memory works. When you remember a loved one who has passed, their presence briefly returns, not as motion, but as resonance. The brain retrieves patterns of connection, electrical echoes of relationships once alive, and for an instant the past lives again in the present. It's a quiet example of how time and life intertwine, neither ever fully gone, just rearranged into new forms of continuity. Perhaps this is why so many cultures have described death not as an ending, but as a transition, a release into stillness. The ancient Egyptians saw it as a voyage through darkness toward renewal. Buddhists speak of it as the dissolution of form, the return of consciousness to a greater awareness. And physicists, though they use no spiritual language, describe a universe that behaves much the same way. Energy never disappears, it changes phase. Time never truly stops, it transforms into geometry, into form without motion. It's tempting to see that transformation as frightening, but it may also be what makes life beautiful. Knowing that every story will close is what gives each chapter its tenderness. The fleeting nature of experience, the fragility of connection, these are not flaws in existence. They are its design. The arrow of time gives meaning to its own disappearance. And so, when the final moment comes, whether for a single being or for the universe itself, it might not feel like falling into darkness, but like sinking into stillness. The distinction between inner and outer, self and cosmos dissolves. What remains is not absence, but peace, the quiet hum of a universe that, even in silence, remembers its song. Just as bodies dissolve into earth, time dissolves into stillness. And if that sounds like an ending, perhaps it's only because we haven't yet learned to hear the music beneath the silence. As we drift further into the story, we'll widen this reflection beyond the personal to humanity itself. For even as we live and think and create, we are also agents of the universe's entropy. We burn patterns into warmth. We trade order for light. We live by consuming the balance around us. The next part of our journey will explore that paradox, how every spark of life, every flicker of creation, is also a small acceleration of time's long approach to rest. If you step outside on a cool night and exhale, you can see your breath for a moment, a small cloud of warmth escaping into the cold. It drifts upward, fading almost as soon as it appears. That single puff of air, so brief and delicate, is a perfect symbol of what life does to the universe. Every heartbeat, every spark of thought, every flame ever lit has released its own tiny cloud of heat, carrying order into disorder, feeding the long, slow drift towards stillness. We rarely think of it this way, but to live is to participate in the universe's quiet unraveling. That might sound somber, but it's also profoundly natural. Life doesn't oppose entropy, it channels it. Every living thing survives by converting concentrated energy into warmth, by taking what is structured and letting it spread. Plants do it through sunlight, animals through food, stars through nuclear fire. Even a single bacterium glowing faintly in the deep sea lives by balancing creation and consumption, turning the improbable into the inevitable. When you light a candle, you create both beauty and loss at once. The wax burns, releasing heat, and for a brief time the room is brighter. The light is a celebration of transformation, stored energy becoming radiance. But that radiance also marks the slow surrender of order. In a cosmic sense, every candle, every sun, every living cell performs the same ritual. We're all instruments of entropy, singing energy back into the void. It's easy to mistake this for tragedy, the idea that existence thrives by hastening its own end. Yet entropy is not destruction. It's the universe's way of sharing. The heat that leaves your body warms the air. The light from a burning star travels across galaxies, perhaps one day nourishing another world. Energy doesn't vanish, it disperses. And in its dispersal, new forms arise. Order dissolves in one place only to appear in another, carried by the same current of transformation. You can see this everywhere if you look gently enough. The warmth from a forest fire rises to sea clouds, which later bring rain to feed new forests. The heat from a cooking stove becomes the laughter of people gathered around it. Even the warmth you give off as you sleep joins the air currents that circle the globe. Every small act of living ripples outward, contributing to the great equalization that physicists call the arrow of time. In the language of science, this process is measured in joules and degrees, numbers that describe how energy moves and how much is lost to heat. But beneath those numbers lies something tender, the realization that warmth is the universe's handwriting, and life is one of its most eloquent sentences. The energy that keeps us alive is borrowed, transformed, and returned. When we eat, breathe, and move, we are participating in an ancient cycle of exchange. We burn the memory of sunlight stored in food or fuel and release it again into the air. Every heartbeat is both a creation and a surrender. It might be fair to say that we are the reason time must rest. Our existence, magnificent and fleeting, accelerates the very processes that will one day still everything. Each civilization that rises, each fire that burns, contributes its fraction of heat to the cooling of the cosmos. We live by burning the past, by consuming the ordered energy left behind by generations of stars. And in doing so, we help shape the universe's path toward calm. This isn't guilt, it's participation. The universe doesn't ask for preservation, it asks for rhythm, and we are one of its ways of keeping time. The waste heat from our bodies, our machines, our cities, all of it joins the cosmic symphony of expansion and cooling. In a few trillion years, the starlight we see tonight will fade, stretched so thin by the growth of space that it will no longer warm even the emptiness. Long before that happens, our small corner of the cosmos will have quieted, our sun will have cooled, and all our energy will have blended into the general hum. Yet even that hum is not meaningless. It is the last note of life's song continuing softly after the players have gone. The warmth we release is memory, spreading endlessly, a testament that order once danced here. In the distant future, when the universe grows cold and dark, that residual heat will remain, a faint echo of all the fires that ever burned. Some scientists describe this future as the heat death of the universe, a phrase that sounds heavy and absolute. But maybe it's not death in the way we imagine. Maybe it's the universe's final rest, the moment when every part of it has shared equally in everything else. There will be no more imbalance, no hunger, no tension, just evenness, the still surface after a long wave has rolled through. We might see it not as an end, but as a kind of universal peace. Until then, life continues to flicker. We build, think, and love. All acts that increase entropy and yet make existence richer. It's a paradox at the heart of everything. We create meaning through processes that, in the long run, erase all distinctions. But perhaps that's the point. Meaning exists only in impermanence, in the brief imbalance between order and rest. The flame's glow matters because it will fade, and there's a quiet grace in realizing that our warmth, however fleeting, contributes to something larger than ourselves. You are right now radiating the same fundamental energy that once powered the stars. Every exhaled breath carries the memory of creation. Every small act of living keeps the cosmic rhythm alive a little longer before it returns to stillness. We live by burning order, by transforming pattern into warmth. That's not a flaw, it's our role. To live is to help the universe remember that it can move, sing, and shine before it sleeps. And as we drift further into the story, this reflection will turn one final time, from the warmth of life back into the cold calm of understanding. What happens when all motion, all heat, all light are gone, and only the idea of time remains? How can we face a universe without clocks, without change, without the comfort of sequence, and still call it beautiful? That's where we'll go next, into the quiet reconciliation between physics and peace. There's a gentle kind of honesty in physics, the kind that doesn't rush to conclusions, that sits patiently before the unknown and says, let's see what the universe wants to tell us. Theories rise and fall, discoveries shine and fade, but what remains constant is this humility, the willingness to admit that reality will always be stranger than our best ideas about it. As one physicist once said, the universe is not obligated to make sense to us. And perhaps, in that sentence, there's something even wiser than science, an invitation to wonder without fear. We've spent a long journey tracing time from its cosmic birth to its imagined end, through singularities and bounces, entropy and silence, light and memory. But at every boundary, every so-called edge, we've found not answers but transformations. Every time we thought time might end, it folded into something else. Geometry, rhythm, stillness, or information. It's almost as if the universe keeps whispering, you're asking the wrong question. Perhaps it's not does time end, but what does it become when our way of counting it fails? Physics, in its clearest moments, doesn't cling to certainty. It listens. When experiments surprise us, scientists don't scold the data. They adjust their expectations. They redraw their maps. Relativity taught us that time is not universal. Quantum theory taught us that certainty itself is an illusion. Each time we think we've reached the foundation, the floor opens into deeper patterns. It's not chaos, it's complexity, infinite in texture, endless in meaning. Maybe that's why so many physicists speak of their work with a kind of quiet awe. They don't see equations as commands, but as conversations, a way of learning the dialect of existence. They know that nature doesn't play favourites, it doesn't bend itself to human comfort or belief. It simply is, unfolding with perfect impartiality. When we speak of laws of physics, it's easy to imagine rules written in stone, but they're more like reflections in water, patterns that shift with our point of view, always consistent, yet always revealing new depths. And so, physics without prejudice isn't just a method, it's a posture of mind. It means letting go of how we want the world to behave and paying attention to how it does. It means remembering that the universe has no obligation to resemble our intuition of it, no reason to share our notions of beginning or end, fairness or finality. The cosmos isn't troubled by being bizarre, only we are. Perhaps this is why the most profound scientific discoveries always come with a note of surrender. When Einstein realised that time could bend with motion and gravity, it wasn't triumph alone he felt, but astonishment. When quantum physicists found that particles could exist in many states at once, or that cause and effect might blur, they didn't declare mastery. They blinked in wonder. The further we explore, the more we realise that knowledge doesn't shrink mystery, it enlarges it. There's something comforting in that realisation. We often imagine knowledge as light dispelling darkness, but maybe it's more like a candle illuminating an endless room. The more it glows, the more we see, and the more shadows stretch beyond its edge. The darkness doesn't vanish, it simply retreats, reminding us that there is always more to learn. And so, maybe the healthiest attitude toward time's paradox, toward all paradoxes, is not to conquer them, but to live alongside them, to accept that the universe can be both continuous and discrete, both eternal and momentary, both knowable and forever beyond reach. Physics is a discipline of precision, but it's also a practice of humility. Every measurement we take, every equation we trust, is written in the language of approximations, and that's not a failure, it's a form of reverence. The human need for certainty runs deep. We want beginnings, middles, and endings, clean stories we can hold. But the universe may not tell its story that way. It might speak in loops and echoes, in fractals and mirrors, in symmetries we haven't yet learned to recognise. If time truly has no end, or if its end is merely a transformation into something timeless, then our search for closure might always leave us one question behind. And that's okay. Because what makes us human is not the answers we find, but the curiosity that keeps us asking. Sometimes I think the most beautiful thing science teaches us is patience. The patience to stand before something vast and not demand understanding, but instead listen quietly for what might emerge. In the same way that a stargazer looks up knowing most of the light they see is ancient, light from stars already gone. Physics teaches us to love the traces, the echoes, the evidence of what was, to appreciate that the act of seeing is also an act of waiting, and maybe, in the end, that's what time is. The universe waiting to understand itself. We, as its conscious fragments, are part of that waiting. Each discovery we make, each observation we record, is the cosmos learning to look inward. When we drop our prejudices and stop insisting that reality must make sense in our terms, we allow it to reveal something of its own logic, one that might be stranger, gentler, and more beautiful than anything we could invent. So, as we approach the quiet close of our journey, let's remember that wonder and understanding are not opposites. They are partners. Knowledge without humility becomes arrogance. Mystery without inquiry becomes despair. But together, they create balance. The same balance that keeps planets turning, that keeps atoms vibrating, that keeps hearts beating. It's not that time ends, only that our way of counting it does. The universe will continue to exist, not as a clock, but as a presence, a pattern, a quiet geometry without measure. And maybe that's enough. Maybe the point of all our asking was never to capture truth, but to participate in it. As we drift further into the story, we'll let this humility carry us into the final chapters. The clocks will fade, the last lights will dim, and what remains will be not despair, but peace. The soft realization that when measurement ceases, meaning doesn't disappear, it simply changes form. Imagine a room with no ticking, no hum of electricity, no window to show the passing sun. You stand there long enough, and minutes lose their grip. Your heartbeat becomes the only rhythm left. Then even that slows until it's just silence. In that silence, time dissolves, not through violence or destruction, but by simple absence. That's what physicists imagine when they speak of the distant future of the cosmos, a universe without clocks. Every timepiece ever built, from the first sundial carved in stone to the cesium atom clocks guiding satellites above us, depends on contrast, something that moves, something that stays still. But in the farthest reaches of the future, contrast will fade. The stars will die, the galaxies will drift too far apart to see one another, and even light will stretch until its energy becomes undetectable. Without differences, there can be no rhythm, and without rhythm, there can be no time as we know it. It sounds tragic, like a slow extinction of meaning. But if we listen more closely, there's another tone hidden beneath that silence. Not despair, but serenity. The universe isn't being punished, it's coming to rest. Every process that could happen has already happened countless times. The final quiet is simply the balance point after a long and intricate song. In the current age, we live within abundance of heat, of motion, of change. A single sunrise burns through more transformations than we could ever count, but slowly, inevitably, those transformations spend themselves. Stars, the great engines of creation, run out of fuel. Planets freeze. Matter itself decays, atom by atom, until the cosmos becomes a thin mist of particles drifting in darkness. It's what scientists call heat death, but perhaps it deserves a gentler name: thermal peace. In that peace, clocks will have nothing left to count. The atomic vibrations that once defined seconds will fade as atoms themselves dissolve into smaller pieces. Photons, the messengers of light, will stretch so far that their wavelengths outgrow the fabric of the observable universe. The cosmos will be vast, still, and unmeasured, and yet even then something will remain. Light, endlessly thin but still moving. Gravity, faint but persistent. Space, expanding into its own quiet potential. The universe without clocks is not nothingness. It's fullness that no longer needs comparison. It's music that has forgotten time signatures but not tone. We often define existence through measurement. We ask how long, how far, how fast. But if the universe continues without time, then existence itself must mean something deeper. Perhaps simply being, without the need to unfold. It's a strange thought, a reality with no before or after, no aging, no decay, because decay requires sequence, and sequence requires time. In such a place, everything that is simply is, forever suspended in equilibrium. You might picture it as the calm surface of an infinite ocean. No waves, no ripples, just depth. The particles drifting within it are like seeds sleeping in darkness, not gone but resting. Space itself may still shimmer faintly with energy, a background hum known as the vacuum field. It's the same hum that allows particles to flicker into existence even now, only to vanish again in less than an instant. But in that timeless future, the flickering may lose meaning. Without clocks, an instant no longer exists. And yet the thought of light still moving is profoundly comforting. Even if no one is there to see it, photons will continue to travel, infinitely stretched, barely whispering their presence. Perhaps they are the universe's last form of memory, each beam carrying within it the history of everything that ever was, every star that shone, every world that bloomed, every thought ever formed, all encoded in a faint wave still gliding through the endless dark. In such a universe, the difference between past and present may blur completely. Without observers to define moments, the cosmos could become a single, vast simultaneity, every event coexisting in a spaceless, timeless whole. From our limited view, it feels like loss, but from a larger one, it might be perfection. A still universe is one that has reached balance. It no longer struggles to change because it has found its shape. The idea can feel distant, but it echoes within us in smaller ways. Think of sleep, that nightly rehearsal for cosmic quiet. When you fall into deep rest, your sense of time dissolves. Minutes vanish, awareness fades, yet you don't experience it as an ending. You wake, renewed. For you, time stopped, and that stopping became healing. The same might be true for the universe. The final rest may not be death, but recovery. The return to a state beyond need or urgency. Some physicists speculate that this stillness might not last forever. Tiny fluctuations, like whispers in the vacuum, could one day spark new beginnings. A burst of energy here, a patch of instability there, and suddenly the silence ripples again. A new universe might blossom, born not from nothing, but from rest. If so, the timeless state we call an ending is only an intermission. The great cosmic concert pauses, then begins again with a different melody. But even if it doesn't, even if stillness truly is the final note, there is beauty in that too. For billions of years, time has been a restless artist, painting galaxies, sculpting atoms, composing life. When its work is done, what remains is the art itself, a completed masterpiece stretched across the infinite. The absence of clocks is not the absence of meaning. It is meaning fulfilled. So, when we imagine that far-off era, the universe without a clock, we need not feel fear. Instead, we can see it as a kind of homecoming. Everything returns to equilibrium, to the quiet background from which it came. The stars that once raged will cool into pearls of memory. The light that once filled our skies will drift into invisibility but remain everywhere, like the faint warmth that lingers after a long embrace. Perhaps timelessness is simply another kind of rest, the universe's way of taking a breath after eternity's long day. As we near the close of our journey, we'll bring that image inward again, back to the quiet centre of human experience, to the still point that exists not just at the end of time, but within each of us, in the small, unmeasured spaces between thoughts and breaths. Take a deep breath. Let it travel slowly in, then let it go. Between the inhale and the exhale, there's a pause. Small, barely noticeable, yet perfectly calm. In that pause, nothing moves, yet nothing is missing. It's not the absence of life, but the stillness that allows life to breathe. The universe too may have such a pause, a still point between rhythms, between beginnings and endings, where all motion rests and all time folds into quiet. We've followed time across the entire cosmos, from its fiery birth in the Big Bang to its distant sleep in the age without clocks. We've watched it twist through black holes, soften into geometry, dissolve into stillness. And now, at the edge of the story, there's no more rushing forward, no more expanding, collapsing, or calculating. What remains is simple presence, the gentle realization that beyond time there is only being. If you listen to the night, truly listen, you can sometimes feel this presence. It hums in the space between crickets, in the faint wind brushing across leaves. It's not sound, but the awareness of sound's possibility, the field that allows everything else to exist. The ancient mystics called it the eternal now. Physicists, in their own way, glimpse it when equations lose their time variable and what remains are patterns that simply are. It's not a mystical escape, it's the most ordinary truth. At this moment, everything that exists is already whole. The poet T.S. Eliot once wrote of the still point of the turning world where the dance is. He meant that even in motion, there is a centre that never moves, the axis around which everything turns. Science has found the same truth in another language. At the heart of every spiral galaxy lies a quiet centre. The arms spin, the stars race, but the core holds steady, anchored by gravity's invisible grace. Stillness is not the opposite of motion. It's what gives motion meaning. Perhaps that's what timelessness really is. Not emptiness, but balance. The point where forward and backward meet, where before and after stop being useful words. The end of time is not a wall we crash into, but the calm realization that we were never really moving at all, that every step, every heartbeat, every flicker of thought was happening here, in this unchanging present, all along. When you sleep, your mind touches this place in miniature. Dreams bend time, memories blend with imagination, and the boundaries between moments soften. You drift into a state where hours may pass unnoticed, where cause and effect are mere suggestions. It's not oblivion, it's peace, your small rehearsal for the great stillness of the cosmos. The brain, freed from its task of measuring, finally rests in the rhythm that underlies all rhythms. The end of time, then, may not be destruction, but a return, a homecoming to that still point that's always been there. The stars might fade, the clocks might stop, but the fabric of existence remains, unhurried and unbroken. Just as silence holds music, just as blank space holds form, the timeless holds all things, waiting quietly beneath their motion. If you think of yourself not as a separate observer, but as part of that pattern, as the universe reflecting on itself, then the fear of ending begins to soften. You're made of the same elements that will outlast stars, the same energy that once burned in their hearts. The carbon in your breath, the calcium in your bones, the light in your eyes, all borrowed from the cosmos, all destined to return. You're the still point and the turning world at once. In physics, some call this recognition symmetry. In philosophy, it's sometimes called unity, but you don't need a word for it. You can feel it now, in the space where thought slows and the next breath hasn't yet begun. It's the space inside you that doesn't age, the part that watches time move but doesn't move with it. The same awareness that existed when you were a child still exists now, unchanged. It's the witness, the quiet centre. In that sense, you're already timeless. And maybe that's the real secret the universe has been trying to tell us. Time doesn't have to end for us to find peace. We only have to stop chasing it. The still point has always been here. In every moment we pause to notice, in every heartbeat that lingers between one and the next. If you've ever watched the last rays of sunset fade and felt that strange, unspoken stillness descend, you've touched it already. So when we imagine the final hush of the cosmos, no stars, no warmth, no clocks, perhaps we're simply seeing a reflection of something that lives quietly within us. The same stillness that holds galaxies in balance also holds your thoughts between breaths. The same peace that awaits the universe at the end of its long expansion can be found here, now, in this breath, in this pause. And as we arrive at the close of this long journey together, let's rest there for a while. You've travelled across billions of years in the span of an evening, through time's beginnings, its arrows, its loops, and its possible end. But the most important part was never out there among the stars. It was here, in your awareness, in the quiet rhythm of listening. Because every time you slow down enough to notice the world, the sound of your breathing, the warmth of light through a window, the distant hum of night, you are meeting the same stillness that waits beyond time. You're the witness, and the universe intertwined. and that realization is what makes everything complete. So now, as the final light of this story fades, let yourself drift. The voice you're hearing will grow softer, the words slower, until only the quiet remains. In that quiet, there is no beginning and no end. There is only the soft pulse of existence, steady and endless. The same now that it always has been. The end of time isn't destruction, it's the quiet between heartbeats. And maybe, just maybe, that quiet is what the universe has been reaching toward all along. Thank you for being here, for listening, for wondering, for sharing this stillness. If your eyes are still open, you can close them now. If your thoughts are still wandering, let them drift away. You are safe, you are small, and you are infinite. Part of the same silence that holds the stars. Sleep peacefully, wherever and whenever you may be.